The purpose of Lab 3 was to identify a system and use visual observations to find the mass of a black hole. This lab is different than the previous labs because we already have knowledge of the motion in the system and are using this information to learn about the net force, whereas in the past labs we made conclusions about the motion of a system from its interactions. In this lab, the system is the star. I used my observations from the model to find the net force on the star. I made an assumption that the only force on the system was the gravitational force on the star by the black hole. The net force was then used to find the mass of the black hole, which I found to be 3.0425 times 10 to the 31st kilograms. The fundamental principles in this lab are Newton's second law and the law of universal gravitation. Newton's second law was used in the form F net equals the change in momentum over the change in time to find the net force on the star, and the law of universal gravitation was used to find the mass of the black hole. I used these fundamental principles when writing my code in Python. I first set my initial conditions in Python. The mass of the star is 1.989 times 10 to the 30th kilograms. The time step is 86,400 seconds, and the initial position of the black hole is 3 times 10 to the 10th meters. The x and y organize the positions and are then derived to give us the x and y components of velocity. Then, when beginning the calculation loop to find the net force, the x and y components of velocity were used to find the initial velocity and the final velocity, and then these values were used to find the initial momentum and the final momentum. I then found the change in momentum and velocity. Next, I set the change in momentum over the change in time equal to F net, which is another form of Newton's second law. dp over dt parallel represents the change in magnitude and is set equal to the change in magnitude times p hat. Because dp over dt parallel plus dp over dt perpendicular is equal to dp over dt, the change in momentum over change in time perpendicular is equal to dp over dt minus dp over dt parallel. When I ran the model, the star moves clockwise around the black hole. It is important to note that the F net direction always acts towards the black hole. What does it mean? F net and dp over dt are often interchanged, but they actually have different meanings. F net affects the motion of the star, while dp over dt tells you about the motion of the star observed. dp over dt is relevant in this lab because we want to make observations and learn about the net force from this. We are using the parallel and perpendicular components of motion, so we want to use dp over dt parallel and perpendicular. What if? If the black hole in the model was removed and a new black hole was placed in the same location, you wouldn't be able to tell a difference. The black hole would look identical and the mass would be the same, because all of the data from the observed motion would be the same.